Hi, everybody. Thanks for joining us this afternoon. We'll get started in just about one more minute. I see a few people are trickling in right now. We do have a lot to cover though, so I won't waste too much time. Hey, everybody. Thanks for joining us this afternoon to learn about Kubernetes and microservices on Azure. My name is Joe Kozlowitz, and I'm a member of the marketing team here at Lunavi. I'm just going to give a quick intro, and then I'll hand things off to our Director of Delivery Engineering, Mike Douglas, for the remainder of the presentation. First, just some housekeeping. If you need to jump off at any time, this webinar is being recorded, and we'll email it out to everybody. As you can see, we have our agenda for today's presentation. We'll be covering some general reasons why you may look to migrate workloads into the Azure cloud and why containers are a great way to deploy those workloads. Then we'll get into Kubernetes itself, including the Azure Platform as a Service, AKS, and 3 typical use cases we see for it, including replatforming, introducing microservices, and building cloud-native apps. If you have questions at any time, go ahead and chat them to me within GoToWebinar. You can also use the Q&A panel if you prefer. I'll be monitoring throughout, and so I can grab Mike to ask them on your behalf. We'll also be reserving some time for Q&A at the end of the session. Okay, I promise I'll get out of the way soon, but I just want to introduce our company, Lunavi, to those of you who we don't work with yet. We're a managed service provider that provides modern applications, cloud services, and data center solutions. I like to say we're one of the only vendors who can take you from data center to DevOps, meaning we provide end-to-end solutions, starting with infrastructure and operations, all the way up to custom app development and business analytics type of projects. We are a Microsoft Gold partner and one of just a handful of Azure expert managed service providers worldwide. Lunavi combines a personal touch with technical expertise. Every solution we offer is focused on delivering quantifiable business value for your organization. We think of clients as partners, and we aim to support you as you scale. I know that digital transformation is kind of the buzzword du jour, but we interpret it as identifying and executing on your key technology initiatives, like managing your apps and infrastructure, modernizing your app operations, gaining efficiencies through automation, and then innovating on the far end through new processes and software delivery. Of course, we do hold numerous industry certifications and security audits, including HIPAA and SOC 1 and 2. With Lunavi, you are guaranteed to hear from a real person within 15 minutes of submitting a support ticket, and we track and report on key performance metrics to enforce our 100% service level agreements. Finally, I think kind of our key difference maker is our delivery team approach, which integrates a self-managed agile team that is personalized to fit alongside your staff. We provide full stack guidance and agile best practices, working with your business stakeholders as well as your IT teams, ultimately providing cost-effective solutions that take you from idea to production. Okay, thank you for bearing with me on that. Without any further ado, I'll go ahead and give the keys to Mike, who will take things from here.
All right, thanks, Joe. Good afternoon, everybody. Let me get my screen set up here. Sure it's still the right screen. Looks like it is. Everything good on your side, Joe?
Looks good to me.
Okay, all right. Thanks again, everybody. My name is Mike Douglas. I'm a solution consultant and the director of our delivery engineering team at Lenavi. We got a few other things here that I like to keep busy and active in our community around here. One thing I'd say pretty proud about is being the coordinator for a competitive robotics club for 4th to 6th graders. It's a really fun thing to see them get active and such. And even though we've got COVID right now, we're still able to participate. So a lot of fun there. Last couple of things, there's some ways to get a hold of me. Happy to always talk and chat about any of these topics and a lot more. All right, so let's talk about our presentation today. So the first thing, before we get into talking about the specific cases, I kind of wanted to start out and talk about, why do we want to move workloads to Azure? So there's a lot of key reasons that you see, and I'd say probably a lot of these are ones you're seeing from different organizations, or as an organization. First one being cost savings, right? So a lot of organizations are wanting to move to Azure to save money and do that there. So I think what we're talking about here is some different ways we could actually see some of that cost savings and take advantage of some of the cloud native features of Azure. Also being able to build applications that can scale, to the internet level and really any, for any needs that they have. So having that ability to do that scaling, auto scaling capabilities there. The third thing, security, that's a really big thing. Microsoft's spending over $1 billion a year on security. So a lot of great security things we can take advantage of when we're building cloud native solutions in Azure. So there's a lot of reasons there. And, it also prevents us from having to, really open up any kind of like firewall ports and things like that within our own organization. Other reasons are just migrating off of, old hardware or even operating systems that may be going out of compliance and wanting to move those out into Azure. So that's another big thing. And then also, really getting that speed of the cloud and DevOps through, being able to deploy and a lot of reasons there that we'll talk about here in the next hour of how to move faster from a business agility perspective. So when we talk about different ways to move to Azure, you've probably heard about the different R's, and we're going to talk about 4 of them, and really 2 specifically, but these I've seen it all the way up to like 6 or 7, depending on what you want to kind of call. But really what we're talking about is just kind of determining what we want to do from a migration standpoint. And this is not just a one size fits all for your organization. Like this should really be something you're kind of looking at for every application you have and deciding what direction makes sense for it, because it really will depend on the application. The first one is called rehost, and from a rehost, that's really meaning we're taking like VMs that are directly on-prem and moving them out to the cloud and do a lot of lift and shift, and we do that a lot. And this, though, we're actually talking about ways to really improve the efficiency of those and leverage the platform like Azure Kubernetes Service. So with that one there, that's a little bit out of scope from what we're going to talk about today. The next 2, though, are exactly what we'll be talking about. The first one being replatform. So with that, it's similar to the lift and shift, but instead of just bringing it up as the exact same way it is today, we're actually going to kind of change it a little bit and really basically replatform it. And that's where we can really take advantage of AKS and containers there. And then the next one, I should say, that we have here is the re-architect. And with that one, we're talking about rewriting it. And we're going to talk about 2 different scenarios of how we can rewrite applications to really take advantage of the power of the cloud and AKS in a couple of different ways there. The final one's repurchase. Again, that's a little bit out of scope, but this would be like if you own a product on-prem and now want to move it to a solution there where it's now maybe you're paying for a subscription for a SaaS solution. So that one again is kind of out of scope here with that one. So when we're talking about migration or in how we're deploying to the cloud, we really want to talk about the way that we want to package up that application. Containers is one of the most common ways to do this. And so if you're not familiar with containers, they're a lot like a virtual machine. but much smaller in size. They require less compute and a lot faster to start and to run. And that's what probably the big difference is a VM is really self-contained with the OS and kernel, whereas some of that is actually shared now on these containers, and that's how they get the full performance of that. Again, that's how we can basically do migrations that are more cost effective and even more flexible than just migrating the straight VM to VM to Azure. And then there's also some advantages from a development standpoint. And the developing, we can basically develop it the same way and on the same image essentially, or same container as that'll actually be run in production. And as a developer, for developers saying it works on my machine and it doesn't work out in production, well, that's exactly what containers can help solve, and basically having to run the same way locally as in production there. And then also too, the flexibility in migrating systems that are both Windows-based and Linux to Azure, so that we have kind of I'd say probably the most flexibility, because obviously not everything can be converted to run on a Linux container. Just a couple highlights here, just to kind of share the impact of this is by 2024, Gartner estimates that 75% of organizations will be running containerized applications in production. I do think that could even be low, really, with both not just applications we're building, but applications that we can purchase too. Here, 42% of those building microservices are deploying them via containers, which I definitely agree with that there too. I think that's a pretty common way microservices are being built. All right, so why, so we're talked about AKS. So why use AKS? And we talked about that. We're saying yes, let's use containers. But what are our options? And there's quite a few options in Azure for using containers. And they really go across the spectrum of the different platform types that Azure offers. And if you're not familiar with these, IaaS is infrastructure as a service. Those are typically virtual machines that you manage and run, do patching, virus protection, and any kind of backups and such there. You control that level. PaaS, or platform as a service, that's really where Microsoft takes care of those underlying OS concerns and just allows you as a developer, as the organization wanting to leverage that, to just worry about the application side of it. And then also the compute of what you need to actually run that. Serverless is very similar to PaaS, except for in this case, you're just saying, here's some code to run, and you're leaving it up to the serverless architecture to decide on the compute. And you're basically just paying for the compute cycles that you use. You get kind of a micro billing perspective there. So those are kind of the full spectrum. So when we talk about ways to leverage containers, again, we can basically deploy those across all of these. Here, the first one, Kubernetes on infrastructure as a service, that really just means I can create my set of virtual machines or virtual machine scale sets and actually deploy Kubernetes myself and actually manage everything. Obviously, that gives me the most control, but also does require the most management there. Service Fabric is essentially Microsoft's flavor of the orchestration platform, similar to Kubernetes. Many of the services in Azure, actually, like Azure SQL and other ones, are actually running on kind of Microsoft's kind of private version of Service Fabric. So this has kind of been productized to allow systems to, or allow different people to run there. So that's definitely an option too. It's a little bit of a hybrid though, but you still have to worry about VMs, and there's some shared concerns there. So that's why I kind of put it into the IaaS window. From a PaaS perspective, we have Azure Kubernetes Service, and that's really what we're going to focus on the rest of the talk here. This is the one we're going to pick out of these 6, but that's a PaaS service, and we'll talk about what that means and how Microsoft manages a lot of the complexities for us. And there's app services. This is one of the, I'd say probably the primary PaaS service that is in Azure for hosting web applications, and it offers a number of options, including being able to host containers or your applications in a container on app services. So that's really good if you have just kind of a one-off, but not necessarily the full orchestration and platform services like AKS will offer. And then the last area here is serverless. There is a couple options here that are, I'd say, more on the serverless side. One's called Service Fabric Mesh. So it's similar to Service Fabric, but you don't have to worry about the underlying architecture. That's in preview, so it's still kind of relatively new there. And then Azure Container Instances, which is a way to basically spin up a container, run it, and then shut it down. So again, you're only paying for when that's actually running. So 3 different ways to leverage, or 3 different kind of platform types to leverage Kubernetes. So a lot of different options that we have there. All right, so now kind of landing on AKS. So what really is AKS? What is Azure Kubernetes Service? So Azure Kubernetes Service represents basically the managed Kubernetes offering from Microsoft. In this case, you really don't have to worry about the underlying servers. You just are just paying for the management services itself. There's what's called the control plane, and the control plane are basically the nodes that provide those core capabilities. So when you're actually deploying an app, or saying this is an application to be deployed, and then the scheduler to actually deploy the application, those are all wanting to run the workloads there. And then when you talk about the workload nodes, those are actually where you're running your application. And so when you talk about the the popularity of AKS across Azure, it's basically of the different orchestration types that we showed, it's really been the choice for like 75%. When it used to be called ACS, Azure Container Services, we had multiple options there of like, was it Docker Swarm and a couple other ones, and Kubernetes really became the de facto standard there. So that's why I'd say 75% is actually done through there, even though that there's a Service Fabric. And that's also one of the fastest growing services in Azure, which is just say a lot, because there's a lot of services out in Azure. But last build they were talking about how much it has been growing. So a lot of momentum behind Azure Kubernetes Service. So you might be going, okay, well, there's a lot of options to deploy my applications in Azure, and you might be wondering, so why should we use Kubernetes and AKS specifically? So when you kind of look at this, especially with the initial applications, you could see, there is some overhead to AKS. So when we look at some of these, the cost per application, when we're talking about a PaaS service, and when I'm talking about PaaS, I'm really kind of more talking about the app services. So an app service, you can actually configure that specifically to what you need. So it's very cost effective to deploy a single app out there and actually run that, versus if you're actually deploying Kubernetes, you're deploying those nodes, and you're not paying for the control plane, but you are paying for those nodes that are going to be running your workloads. So if you're deploying, let's say, 2 nodes, that's really 2 VMs behind the scenes. So those 2 VMs are, you're basically paying for that full cost for just one application. So you are paying a little bit more to start out with. So that's why there's a little bit more from an AKS perspective. Now, when you talk about like management and managing those applications, there's a lot of things to learn from an AKS perspective. You've got the just the AKS service itself in Azure. You've got Kubernetes with like kube control. You've got Helm, which is basically a kind of infrastructure as code for deploying workloads to AKS. You've also have Docker and all the commands from a Docker perspective and containers. So there's a lot of stuff to learn. So from a one-off or just from a few applications, it will feel like this is more work than just deploying, zipping up a PaaS service and deploying it out to there. So definitely initially some easier from there. Pipelines, kind of similar. So if you're deploying your application to a PaaS service, it's actually pretty easy. You just add a task out there that says deploy to app service, specify the zip folder or zip file or folder, and it's deployed. When we're talking about it from an AKS perspective, typically when we're building systems for AKS, we're doing a container. So our first steps will actually be to build the container image and then actually publish that to a container registry. And then from an AKS perspective, we tell it to go ahead and deploy to it and things like that. So there's definitely more steps to deploying it from a pipeline. We talk about access restrictions. So there's really not much work to do from a PaaS perspective of one-off application or a handful of applications. Basically whitelisting that application, so maybe only our application gateway can get to it instead of all of our applications. Versus with AKS, like understanding exactly how like our egress controller works, their clients there, and so forth. So those can definitely be more complicated. The next thing is infrastructure as code. This is where we're using ARM templates to deploy our services. When we're talking about just a handful of applications out there, the infrastructure as code is not too hard to manage from a PaaS perspective. It's not too difficult either from AKS perspective, but as we build more applications, you will see that kind of flip a little bit more. But in general, the infrastructure as code is not too hard to manage, and our security access restrictions within there. The last thing is kind of comparing between the two is distributed tracing. So when we're talking about how our application is, being able to be traced across the different services, and also too, kind of relating there is actually like local debugging and running local there too. It's really not too hard to run a few of our PaaS services, but if we're trying to run like AKS and things like that, there is a little bit more work to do for those types of things. So in general, we're talking about just a couple applications. Even if you haven't deployed or migrated applications to Azure yet, I might even say start with your PaaS services, and then as you start to grow that out, that's where you can start looking at a platform like AKS. So, but as we grow this into more applications, you can see some of these things that were pretty easy to do from a PaaS perspective become a little bit harder to do. And one of the reasons I kind of think of it like an island is you think about each PaaS service being its own individual island versus AKS is kind of one large island in itself. And so you have to manage a lot more things at each of those islands versus just managing it as one with AKS. So I think that's kind of a key piece there. And so a couple of the highlights with that, your cost per application, now we can actually host and utilize a lot more of the resources on those nodes when we're deploying more applications. And I'd say one of those things about it is you're actually scaling. So if you could argue and say, well, I can use an app service plan across multiple of my PaaS services and kind of share some of that cost like we're doing with the AKS nodes. That's true. But if we want to actually scale up our PaaS services, we have to scale up the whole app service plan together. So we have multiple applications. We're now scaling up all of our applications. So if we're trying to get to a certain level of support for our application, we're now having to scale it up even higher so that our entire application can scale at a level versus lower. Whereas with AKS, we'll be able to actually scale up individual pods or applications versus the whole entire nodes there. So definitely a lot different with that. The pipelines, they don't really change, but and kind of with management too, like if we're all doing the same thing, it just becomes the way we do it. So as long as we're all kind of doing the same thing, that management, I'd say kind of level goes down. Still, you still need to know a lot of different things, but you don't have to know, it's not going to be different than everything else we're doing. One thing though, the access restrictions and infrastructure as code, that's a key piece that we've seen get more challenging to manage as we grow out the PaaS services, because we might have a PaaS service be talking to another PaaS service behind the scenes. So those services will have to actually like create some access restrictions around those. And some of the times if the service isn't even created yet, it's kind of hard to add those as like a whitelisting they might have for that. You can do some things like through like service endpoints or private endpoints where you can actually manage it on the subnets, which makes it a little bit better, but it's still a little bit more complex, whereas it's pretty straightforward. You can do it straight through your service manifest or your deployment manifest in AKS there. And the last thing is distributed tracing. So it is easier to do. As we're building out more and more services, it becomes a little harder to kind of manage across those different islands, again, from a pass perspective, especially if you're trying to run multiple applications and debug them. You have to kind of simulate that environment locally. With AKS, there's actually some tools. There's like Azure Dev Spaces, and then a new one now, the Kubernetes for I'm trying to blank on the name, but those types of things you can actually debug locally a little bit easier. And then from a tracing perspective, there's some things that can help you, like service meshes and a tool called Dapper, DAPR, that you can use that will actually run as what's called a sidecar in your pod and allow your application to use it to do all your tracing, and provides a lot of other cross-cutting capabilities that you might have. So therefore, when we're talking about building out these applications and we start getting more of them, that's where I think AKS really shines and really can help. We can leverage those capabilities across that. All right, so let's start talking now that we've got kind of that foundation of, why and how we're talking about how we want to use to move these workloads to. Let's talk about a couple of these, scenarios for actually migrating applications in Azure, or I'm sorry, AKS. The first one, again, I wanted to talk about was that replatform. So again, we're trying to lift and reshape. So what does that look like? What are kind of our requirements for this? This one here is we want to basically maximize our cost savings on this approach. So that's why we wouldn't do necessarily a straight VM to VM migration. And we really want to make sure applications are able to be migrated with minimal modification. So that's where we wouldn't want to, do a whole lot of changes to be able to support running in Azure. But because we do have some applications that are 15 plus years old, running basically ASP.NET Web Forms, and those still need to be running, still running business critical things, and probably some of these we don't even have source code for, which is a little bit scary. But these are definitely applications that we want to move out there and start running there. We also have some applications that are newer and more modern, so we're able to actually take advantage of that. And then we've got, not everything is an application that we need to modify. Our applications are leveraging databases and other things like maybe file shares for using those applications. In this case, we've got SQL databases that need to be migrated also, and so that's something that we need to be able to do. So those are kind of our requirements. Hopefully, you probably can relate to some of the types of things that we need to do in this scenario. This is where we want to then take advantage of. This is a great great way to take advantage of AKS. So in this case, what it looks like is we have our on-prem virtual machines. In this case, we've got one running on here called our application A. Here's our Kubernetes or AKS cluster. One thing you'll notice is we have both a Linux node and Windows node, because not everything will be able to migrate to one or the other. I mean, we could probably migrate everything to Windows, but Linux will give us some extra capabilities. We'll talk about that here in just a minute. So we have that set up, and what's nice is AKS supports both of that. In this case, we have a more modern application that we built. This was made in .NET Core. We're able to actually move that straight over to a Linux node and run that in a Linux container. Whereas we have now another application. This one's an older one. This might be that Web Forms application that I was talking about before. But this can be migrated to a Windows container and actually run on a Windows node. So we can still containerize it to have that run. And then the last thing is our database, and how we could run the database inside the cluster, but for the most part, what we've been doing is deploying those more just to the PaaS services. So we move the applications to our AKS cluster, And then from our application database perspective, we're actually deploying those with PaaS services. So you might be wondering, why or what's the criteria between our Windows and Linux containers? Well, a lot of it depends on what we're running from an application perspective. So if our application's an older .NET application, we might not have the source code for, or we don't want to modify it, we can actually run that on a container called Windows Server Core. And you can see there, it's, basically it's like running a miniature version of Windows. Has IS on there, some other services. The downside is Windows containers are much larger than Linux containers. So this one in particular, it's compressed, it's about 1 gig, and it runs anywhere between like 3 and 6 gigs, which from a VM perspective sounds pretty small. But Linux containers here, if our application was like .NET Core, or we could upgrade it to .NET Core, some of those Linux containers are just like a few hundred megs. So you can see quite a bit smaller to run our applications and requires a lot less resources when we're talking about memory and CPU. So we can run a lot more applications on that. There's also Windows Nano Server here. So we're wanting to run all Windows. That's another good option. The Windows Nano Server is much smaller, and it allows us to run the application there. But I still would say there's some advantages to running the application on Linux over that. All right, so as a result of this, what are some of the benefits? Well, we get a lot of cost savings. We've seen up to actually from a Windows perspective, 30%, so even more from a Linux perspective, but basically lower cost than just moving them to virtual machines there. With our Windows ones, we get not quite as much cost savings just because we have to run it on larger containers, which will take up more of our memory and CPU. But our Linux containers, we can definitely run those on. We can run this .NET. I'm sorry, the .NET Core applications can run on the Linux containers. As I showed you, one of the benefits is we can actually leverage the same AKS cluster for running our applications, and that gives us a way to minimize the number of them. Now, we typically would do like an AKS cluster for dev, test, and prod, but we can keep those together so we're not deploying a whole bunch of things. And then just right out of the box, without even doing a whole lot, that can give us some additional resiliency and scaling capabilities, because now we have our application deployed in a pod and we can deploy it across multiple nodes and even scale it up across there. Now, obviously, I'd say a lot of applications I've worked with that were legacy are very stateful in building that. I'm sure you've probably seen that too. So sometimes those stateful applications, have trouble scaling out. So if one request comes in from one kind of running instance of it, and then comes back to a different one, won't be able to know what the previous state was of that. Obviously, the more modern applications we're building are stateless, so those kind of scaling capabilities are much better. But for some of the older systems, that can definitely be a challenge. So we want to definitely add. We might have to do some things like sticky sessions and things like that from a deployment perspective. And then the other thing, like we talked about there, is we can still deploy things that are not going to be in AKS and leverage it in AKS. In this case, SQL Server is a perfect example. We're going to still migrate that to be a PaaS service, and but not be part of our cluster. And that still gives us a lot of advantages, because I'm guessing when we're migrating it from was a cluster of SQL databases. On-prem, we usually do clusters to be more cost savings, but it also makes it more restrictive on when we can do upgrades and things like that. Whereas now we're actually just deploying the SQL Server for that application. So it makes it so you can then right size it and just pay for what you use there. And that way, if you need to upgrade it or do something, you don't have to worry about taking down somebody else's database, because yours is just application specific. It's really important there. So those are kind of the benefits we get out of that first workload. So let's talk about the next workload. This is one where we're migrating our applications to microservices. And so this one's, we're touching more on that re-architecture. In this case, our scenario is where it's a legacy application that we can't completely rewrite. And we've probably run this quite a few times because a lot of times we're rewriting an application. The MVP of that application doesn't always do what the old application does. So it's really hard to justify, even if it does a lot of things better, if it doesn't have all the same capabilities as our legacy application or the previous version, it's hard to still get the business to say, yeah, let's deploy that better version with less features. Now, if you've got features that aren't being used, that's one thing. So this is kind of an example like that, where we can't go rebuild the whole thing. We have certain parts of the application need to handle more load. And it's not the whole application, because it's really too big of a system to try to scale the whole thing at once. So we need to be able to kind of isolate those parts of the application so we can actually handle more of the load. The other parts of it is we're actually going to leverage what's called the strangler pattern, if you're familiar with that. And that's a way we can actually re-architect parts of the application without impacting the overall system of that. So let's take a look to see what that looks like. In this case, we have our legacy application. It's like an MVC UI, which calls some backend services. And in this case, that's the legacy system. What we can have is this strangler piece that kind of fits in the middle that will identify, is this something that's been rewritten into the new kind of architecture, or is this something that's still part of the legacy one? And so it'll be redirected there. This strangler piece can be located at different areas. It might not be here right at the MVC level. Maybe it's at the beginning of the MVC site. But essentially, as we can pull pieces out of the legacy system, we can rewrite those into microservices. And eventually, all that legacy system will be rewritten. The one challenge we can have with this is, like, let's say we were building an MVC UI for this, is we can't kind of start converting half of it to like Angular React. That gets a little harder to do. So typically in those scenarios, we'll get enough of the backend services rewritten, and then we'll update the UI to really make those same API calls, and then maybe optimize them a little bit later for like a small architecture. So that's kind of the second example. So some of the some of the benefits of that would be is to incrementally change, those incremental changes that we're doing, we can get value to those immediately. What's really nice about that is our typically when we're doing a major rewrite of an application, the application takes a long time, and we're not able to get any value out there. So the organization's investing a lot of money in this new version, but really not getting any ROI on that until we can release it. So by doing this, we can get that ROI as we go and continue to keep basically funding the next change to it. The nice thing is this all happens behind the scenes. So our existing applications will continue to work while those kind of back-end pieces are being changed out. This also, with these individual microservices, allows us to independently scale those for performance. So now if just one piece is what's getting that needs the to be scaled, we don't have to scale the whole thing anymore. We can just scale that one part. And that's a huge benefit because there's some parts where there's a lot more to that. And then eventually, after we do a lot of this, the application, we can essentially have the whole application re-architected in this new pattern there, and basically be getting that benefit again throughout this entire process. So that's really the second scenario of it. Our last scenario here that we're talking about is, again, another re-architect. migration way, but this is where we're actually doing a new, basically Greenfield cloud native application. In this case, our scenario is we want to rewrite the existing system. So in this case, we do have the green light to rewrite the whole thing. And a lot of times it's because it's more than just something we can kind of piecemeal. And in this case, for this application, the UI and UX experience was really reimagined. So the old system almost didn't make sense when we got done rewriting the new one, or writing the new one. Essentially, we really didn't use any of the existing logic or functionality. It was really built from the ground up. And this is one too where there was a kind of the SLA on it was very high. We needed to make sure it was redundant, had the resiliency to failures in there, and then meet fluctuating demands. So I had to really do all those things from the beginning. So we really just built those into the process and really built it. And the other piece was it needed better supportability. Like the legacy system actually had hooks in there for supporting, but we wanted to make a system that could provide a better window so that the users didn't have to do kind of some like a backdoor process to improve that supportability. And then the last thing is really being able to increase the speed of delivery so that our application could be deployed quickly and secure. So what did that look like? So in this case here, it was an Angular application. So the front end was leveraging the Angular SPA application. And in this case, we had an ingress controller kind of managing basically working as an API gateway to our different services endpoints. We're using Nginx for that in this case. And then we're also doing a couple other patterns here, like CQRS, if you're familiar with that. It's kind of a way you can do some commanding for your insert updates and deletes, and then having a separate way to kind of do your selects. So that's where our coding system was leveraging that, and leveraging event sourcing. So kind of giving that recorded playback so that each change is recorded as a new change. And then being able to do some projecting when we're doing our selecting, so we can basically get back to the projected values and changes in more of a document database versus having to pull out from the event store all those changes. You see the different services here as this application, as we continue to develop it, we're continuing to add more and more services. And one of the key pieces that we wanted to do was not have our application depend on or get more complex, I should say, as we add more services there. And the other thing too is we're doing here is we're doing a lot of eventing between our services so that our architecture is very event driven and not having to have our services tightly coupled between them, so we can make sure that those service calls are all happening asynchronously to really impact the performance of the application from there. So this is our Greenfield layer. One of the things we wanted to make sure as we were building our application, it was built with that security and from the beginning. And with that, this is where we included like a very secure way to do CI/CD. In this case, we're using Azure DevOps as our tool. And with this, our process for building our these custom images with our application on them, we wanted to make sure that they were being secure. So we did things like scanning the code for security. We're using third-party libraries in there, and we wanted to make sure, we were wanting to make sure our code was secure, but then also two, we wanted to make sure that the code was the code in this case that we were using for third parties was also secure. So we're scanning to make sure we weren't using any like third-party packages that had vulnerabilities. We packaged that up, submitted that to our container registry, and then from there, we were actually doing our deployments to Azure, and there we basically we configured the deployment, and then we configure our service. So in that case, if you notice, it's not like a push. We don't push the application to AKS. We're basically saying, hey, AKS, here's how we want this to run at all times, including the first time. And so we basically give it that desired state, if you will. And then AKS basically satisfies that. And then we'll go pull the image out of the registry, spin it up, and basically get it running out there in the environment. And then we'll do things like run what's called the DAST scan, dynamic application security testing, very similar to like a pen test, where we can basically make sure that all of our public endpoints are meeting any kind of vulnerability there. So that's really how we did it. We're starting to get into some more of the kind of container specific security, where we can actually scan the images in our container registry using a tool called Aqua. So that's a way to make sure that our applications are staying secure there. So benefits of this really gave us those DevOps practices from the start. First deployment to the last one, gave us the ability to release with speed, gave us that security, met other security kind of requirements, and with quality. So we could deploy really when we needed to. The other big piece is we wanted to make sure, like, adding additional services, because we continue to do that, didn't make it more complex in our development and deployment processes. It's because we wanted to be able to make those secure there, or we wanted to keep it the same. Obviously, adding more services, we have to do those deployments, but there were times where we were doing this before, where each service added some basically exponential complexity, and that's what we're really trying to avoid there. The other thing is we want to really make sure that the application, we're able to make the application be able to run for any kind of internet scale or any workload there. So that's our final example that we wanted, or scenario that we wanted to talk about. So I just wanted to wrap up here and really talk about how we're able to leverage Azure Kubernetes in a lot of different ways to be moving these different workloads to really give us those benefits I think most organizations are looking for, whether that's cost savings, whether that's the scalability, and really that kind of pay as you just for what you need model with Azure. Also being able to deploy our applications to meet in a secure way, and then to get off the legacy hardware or operating systems to a more modern platform, and just give us that speed and business agility. So with that, I would like to open it up for any questions that anyone might have.
Thanks, Mike. Everyone's still muted, but feel free to chat your questions or use the Q&A. We'll hang around for a couple minutes. Mike, I did have one question that had come in on the migrate to microservices path. How would you go about deciding which components or services to refactor first as part of that strangler pattern?
Yeah, great question. So I think one of the key things is I'd go by a need basis. So like I mentioned in that scenario, is there was a specific service that are a part of the system that had to work under load, or had to basically scale higher than any of them, because it was from like a negative scenario might happen with that one, where if that happened, essentially the usage would just go way up. So that's why that in that case we chose that particular part of the application. So we kind of prioritized it by what we really needed to do from like a scale and resilience standpoint. That's how I would kind of look at it, and just like kind of the backlog of stories are prioritized. I would look to see what part of the application really needs it the most, and start doing it that way.
Great. And then this is actually just from my own curiosity, and that is, what type of learning curve do you see when you're working with clients introducing Kubernetes and containers compared to kind of traditional VM management?
Yeah, so I'd say probably the biggest thing, I mean, so I guess there's two parts to it. One is the development side, and then two is the operationalization of that. I'd say from the development side, the developers are pretty good about picking that up, and I'd say they would never have really been concerned with it on the VM side, but from a development side, uh, they're pretty good about picking up those skills. A lot of the tools, especially we leverage Visual Studio and VS Code. There's some pretty good capabilities in there for using Docker and Kubernetes that really help. So that part's not too bad. The operationalization, I would say, is probably more because when they're very VMs, they're very comfortable with on-prem. So moving VMs to the cloud, they're very comfortable with. I think with doing like a brand new platform like AKS, there is some learning and some there. We do some workshops a lot of times with the clients, and we actually do some like we kind of do some failure monitoring where we actually like break stuff in the environment, and then we'll actually have them work a lot of times with the developers to troubleshoot and figure out what the problem is, to really give them that confidence that they can do this. But really, it's just some different tools, and a lot of the tools in Azure are similar from a management standpoint. So I think it's just getting them comfortable that with the actual maintenance of it, and understanding where things are a little bit different with a container versus with a VM.
That's actually a perfect segue. I just got a question from Andy asking, what tools do you use to manage AKS?
So, so from a tools standpoint, I guess, there's definitely I guess there's a couple of them. One of them would be from I guess from the operation side, the application insights and log analytics provides a lot of good ways to manage those. There's a lot of built-in now, I'd say AKS specific capabilities there to drill into the different nodes and different components there. So that's probably the primary one that we're using with it. We basically do a lot with the Kubernetes with App Insights.
Awesome. I don't have any other questions at the moment, so just want to say thank you to everyone for joining us today. Got anything else, feel free to shoot it over, or you can reach out to Mike or myself directly. And I hope that everyone has a fantastic remainder of their week.
All right, thanks everybody.